To find the Thevenin equivalent circuit of the load resistor in this case, so we have our bridge network circuit, and we're looking for a Thevenin equivalent circuit to everything else around this R load right here. So we've marked our terminals A and B, and I'm going to redraw. So the first step is going to be to find R Thevenin, and that's where we set sources to 0, and then find RT at A and B. Okay, so always redraw the circuit. It really does help, especially in cases like this where it might be a little harder to see without redrawing what's going on. And then, so we've got, I'm removing the resistor, the load resistor from A to B. Uh, 3 ohms, 4 ohms, 12, and 6. And we've got a 72 volt source here. Now R Thevenin, to find R Thevenin, we have to remove our voltage source. And when we remove the voltage source, we of course set that to 0. So when we set a voltage source to 0, that shorts it out. Then we're going to take our ohmmeter right here and connect it to our terminals A and B and measure the resistance there. So this is a little bit tough because we're going to have to talk about how these are all connected. So from A, that side is connected to the 12 volt source, 12 ohm resistance, and it's connected to the 4 ohm resistance over here. And it's connected to the 6 ohm resistor on the other side and the 3 ohm resistor over here. So on the other side of the 6, that's connected to the 12. But notice it's also connected all the way over here to the 4 and 3. So that's interesting. So basically, your 6 and your 3 are in parallel because they share this point in common and they share this point in common. So I'm going to draw that, the 6 and the 3. Now the 12 and the 4 are also in parallel because they are connected on one side here and then also over here as well. So I'm going to draw that in. Now, where is A and where is B? Well, A is over here between the 4 and the 12, and B is over here between the 6 and the 3. And on the other side, these are all connected to each other. So that's really what we're looking at here. So when I put my ohmmeter here, remember it's going to put a little bit of current into the circuit. That current splits here and then comes back together over here. Splits here and comes back together here. So basically I'm going to combine these two resistors and these two resistors and then simplify a little bit so we can see that. The 6 and the 3 in parallel, that becomes 2. The 4 and the 12 in parallel becomes 3. So when I draw this again, I basically have 2 ohms over here and 3 ohms over here. So now I've got basically a series circuit, so R Thevenin would just be 5 ohms. And I'm going to write this up here just so I don't lose it, because remember this this step doesn't really affect my next step, and keep them separate. You have to keep these two steps separate. So step 2 is to put my voltage source back in the circuit, which was a 72 volt source. And I'm going to draw everything else. It'd be nice to make this a little bit neater. I'll have to work on those drawing skills. And you should be too. You should be drawing all of these circuits with me. 12, 6, 4, 3, and 72 volts. Okay. So what do we have here? And so our next step at A and B is to grab our voltmeter and connect the red lead to A and the black lead to B. Okay, try to keep those straight, because the reason we need to identify the red and the black lead is because we're expecting this side to be more positive than this side, and if that's not the case, we need to know that. So it doesn't matter that, you know, the red goes to A and the blue goes to, and the black goes to B, except that we're looking for the direction of the voltage. Okay, so how do we measure that? Well, what we need is the voltage here and the voltage here, and then we'll take the difference of those. And so remember, there's a voltmeter here, but this is actually an open circuit right there. So to draw this so that it makes a little more sense for you, I'm just going to show you when I flatten this out a little bit, this is basically what we've got. Where there's B and there's A. Okay, so notice what we have here. We've got a 6 and 3 in series and a 12 and 4 in series. And what are these? These are voltage dividers. Okay, series resistors divide the voltage. And what voltage do they divide? The 72 volts. Okay, you've got 72 volts here and here. And a portion of that's going to be across the 3 ohm resistor, and of course a portion across the 6 ohm, just as a portion of the 72 will be across the 4 and the rest of it across the 12. So in order to find our voltage drops, there's a couple ways you can do this. You can find the current here and the current here. That's just fine. Or you can use your voltage divider rule. And notice the voltage here at B is the voltage across the 3 ohm resistor. So using the voltage divider rule, we would take 3 over 9, that's the, actually I'm just going to write 6 plus 3, so you know where that came from, times the 72 volts. So basically a third of this voltage is what we see at B. And that's 24 volts. And then the voltage at A, that is the voltage drop across the 4 ohm resistor on the right. So voltage divider there would be 4 over 12 plus 4, or a fourth of 72. And that would be 18 volts. So E Thevenin is actually going to be VA minus VB. So we've got 18 volts at VA minus 24 volts at VB, and that's a negative 6 volts. Now, why does it matter that's a negative 6 volts? Because I'm going to orient that voltage source in such a way that we see that it's negative. Okay, so back up here. E Thevenin is a negative 6 volts. So what that means is when I draw my Thevenin equivalent circuit, which I'm doing right now, I'm going to orient this voltage source so that the positive terminal is down facing ground, There's my 5 ohms. And then here is A and here is B, and I'm just going to put back my load resistor, RL, and that's my Thevenin equivalent circuit right here. So basically I can change RL all day long and have a much simpler circuit analysis than if I were using this circuit right here.